This video is on wave calculations. So you watched the previous one about what wavelength is and what frequency is. So now let's relate them to each other. So the speed of a wave equals the wavelength times the frequency. So speed of a wave is, we're going to use the letter C, and I'll come back to why it's that in a second. Wavelength you learned in the last video is this lambda, and frequency is nu, this Greek letter right here. So speed equals wavelength times frequency. Think about the units here. So speed, right, any sort of speed is going to be a distance unit over a time unit. For us, it's going to be meters per second. Wavelength would be in meters then. And frequency, remember, is hertz, which is the same as 1 over seconds. So if I write this as 1 over seconds, I hope you can see that meters times 1 over seconds equals meters per second. The reason we're using C for speed and not like V, like velocity, like you've done in physics or in 9th grade physical science, is the speed of light is, we use the letter C to represent that. So not just any speed, the speed of light. And the waves we are talking about here are traveling at the speed of light. So the value you need to know, and you're actually going to be given this, but you need to know what to do with it, is the speed of light is 3.00 times 10 to the 8th meters per second. So if you wrote that out in standard notation, that would be 8 zeros. So 300 million meters per second, which means that light travels 300 million meters in a time of 1 second. That is extremely fast. Extremely, extremely fast. All right, so here's an example of a problem you might see. Let's say a student's listening to an FM radio station B96 while they're doing their chemistry homework. The radio station has a frequency of 96.3. That's where the number on the radio dial comes from. It's the number of megahertz, really, so hertz, that we're going to deal with right here. So here's our hertz. If radio waves travel at the speed of light, what's the wavelength? So if I list out what I know frequency, 96.3 times 10 to the 6 hertz. They travel at the speed of light, so C equals 3.00 times 10 to the 8th meters per second. And the question is, what's my wavelength, or what's their wavelength? All right, so I like to do my algebra with my symbols, not my numbers, because those numbers are much longer than writing just the one letter, one symbol. So I'm trying to write less and just write my numbers one time. So C equals wavelength times frequency. If I'm solving for wavelength, I'm going to divide both sides by the frequency, which will get this to divide out. So my wavelength equals my speed over my frequency. So now I'm just going to write my numbers one time. So 3.00 times 10 to the 8th meters per second divided by 96.3 times 10 to the 6th hertz, or I could write it 1 over seconds. So I can see unit-wise that the seconds in the denominator in both these units cancels out, and the unit I'm left with is meters, which is good, because that's a wavelength unit, right? Length, distance. So now make sure you can type this in your calculator, and you remember how to use that scientific notation button, which is probably this on your calculator for most of you, and it replaces all of this part right here. So you're typing in 3, and then your EE button, and then 8. Divided by 96.3, your EE button, 6. All right, so you should get on your calculator an answer of 3.12 meters, because we can only have 3 significant digits. So this is the wavelength for a wave, the radio waves when you're listening to B96.